All right, so in this video, we're going to be doing triangle proofs, and they're called two-column proofs because you have two columns, okay? Statements are going to go on the left side of the column, and statements are like congruent statements. So like angle L is congruent to angle M, okay? We're going to learn about reasons in a second, but congruent statements are going to go on this side, and then this is just the justification, okay? So you'll have things called givens. You'll have the whole side, side angle, side, that's an S. You'll have things like vertical angles over here. You'll have things you'll learn, okay? That's just a preview. So, some things over here. The reflexive property and the symmetric property. So remember yesterday when we could make the mark on this right here to do side, 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 okay? When you make that mark, it's either called reflexive or symmetric by how you name it. So for example, let's give me two letters, A and M. So reflexive is going to say AM is congruent to AM, okay? They have the same letters, okay? Symmetric is going to be like symmetrical. It's going to flip-flop. So you would have AM is congruent to MA, okay? So that's just if you want to name it with two letters that are the same, your justification would be the reflexive property. Symmetric property is when they're symmetrical on both sides, kind of like a mirror. So you're going to have to kind of memorize those. Again, we learned yesterday we can make marks because of vertical angles. Also, midpoint, if something is the midpoint. For example, if this M was the midpoint, I know that this mark is the same as this mark. So that would be an example of a justification. Also a bisector with angles. So if I know that AM is a bisector, I can make that mark and that mark because I know they're the same because it bisected it, okay? But we'll get some practice with that in a second. So let's talk about reflexive versus symmetric, okay? So here are several examples. I want you to either drag, which you can't drag and drop, so you're going to write them where they go. So for example, if you think AB should go under reflexive, stick it on this side. If you think it should go on this side, stick it on that side. So take a second and press pause and write them either on the left side or the right side, okay? And then we'll go over it. All right, so hopefully you got these are on the reflexive side because they are the exact same letters written in the same order. And then hopefully you got these guys for the symmetric property because they are symmetrical. They flipped over a mirror, okay? All right, moving on. What is a given, okay? A given is something that is marked or they're going to tell you, okay? So for example, here's what a proof is going to look like. It wants us to prove that triangle KJL is congruent to triangle MNL, okay? So notice I have a lot of statements down here. And what I need to do is I need to place them into this left column or this right column, okay? So and a given is going to be this mark. So for example, see how JL is marked and LN is marked. Okay, let me find JL and NL, okay? Here it is. So you're going to have to write it, but I'm going to drag and drop it. No. All right, so they told me in this picture that JL was congruent to LN, okay? They gave that information to me, so it's called a given, okay? They also gave you another given. They said KL was the same as LM or ML, so that was another given they gave us, so I'm going to write given, okay? So notice your givens are always going to go at the top of the page, okay? They have to give you something, whether it's in writing or whether it's in a picture, okay? So now we know that we can make some angle marks, okay? I know that those angles are congruent because they're vertical, okay? So that would be KLJ is congruent to MLN. So that's going to go on the left side of the column. The reason I can mark them are because vertical angles are congruent. Okay, now the cool part is your very last proof, because I want to prove that these triangles are congruent. Whatever they want you to prove always goes in the bottom left. Okay, I'm trying to prove that those two angles are congruent. Now the reasoning is the last one is going to be what we learned yesterday. So side, 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 side angle, side, etc. Okay, so I have proven that this triangle is congruent to this triangle because of these things. Okay. So notice you're going to have three kind of informations before you get to prove that those triangles are congruent. Okay? So we're going to do a little bit of drag and drop for the next couple times, but you are going to have to eventually come up with these on your own. Okay? All right, but let's move on. All right, so it wants me to prove that triangle ADC is congruent to triangle ABC. Okay? Now, notice they didn't give us any markings in the picture. So what I need to do is they gave me some givens. Okay, so I know that AD, which is right here, is congruent to AB. So I can go ahead and make those marks, and I can put them in my table. Okay, so I'm going to start off with that, and that was a given. All right, my next given was DC, so give that 2 marks, was congruent to BC. So I also need to put that in my table, and then that was a given. Okay, so now I've got 2 marks, and I need a third, and I know that we can make this mark based off of yesterday. Now it's just how I name it, okay? So they named it AC is congruent to AC. You could name it something different, okay? But the reason that AC is congruent to AC would be the reflexive property, okay? So if you said AC and CA, that would be the symmetric property, okay? So lastly, my proof is going to go at the very bottom left, and the reason those triangles are congruent are because of side, 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 okay? So again, they can give you givens in words, or they can give you pictures in the diagram, but you're going to have to mark the givens first. Typically, it's a vertical angles are congruent, or reflexive, or symmetric for this third step, and the very last step is to prove that the 2 triangles are congruent, okay? All right, why don't you try these 2 on your own? So try this one, and then try this one, and press pause, and then we will go over the answers. All right, so on this picture up here, it gave me AC and EC were congruent, so that was a given. It also gave me BC and DC were congruent, so that's a given. Again, my last step was I noticed vertical angles, so it was just naming those angles. Again, you can't name it angle C because I don't know which one you're talking about, so you got to give me ACB. And then ECD are congruent because of vertical angles. Again, lastly, I've got side, angle, side. Okay, and again, your proof always goes bottom left. All right, the other example, a little bit trickier. So it gave me JK and NK were congruent, given, and it gave me A as the midpoint of JN, given. Okay, so you kind of had to make 2 marks right here and here. Okay, I started off with this AK mark because that was either reflexive or symmetric. And if you say AK and A, or KA and AK, that would be the symmetric property. Again, if you named it KA was congruent to KA, that would be reflexive property. Now, we've never done midpoints before on proofs, but we do know that if A is the midpoint, then I know that this piece is the same as this piece. So what I did was I said JA was the same as AN because that's the definition of a midpoint. Okay. So lastly, I proved that those 2 triangles were congruent by side, side, and side. Okay. So hopefully this is getting a little bit better. Why don't you try this one and this one on your own, and then we're going to get into blank reasonings. Okay. So try those 2 on your own and press pause, and we'll go over them. Problem, they gave you too much information because we're trying to get you to reason through what you need and what you don't need, okay? So notice I put my 2 givens first, and then I know that I could mark this third side because of reflexive or symmetric. Notice they named it using the symmetric property. So then you've got angle, angle, side, okay? Again, the proof of the triangle always goes at the end, okay? Next one. A little bit trickier because they brought back parallel lines, okay? Remember, if you've got parallel lines, you can have alternate interior angles, okay? So I wrote my 2 givens first. I made this mark because of the reflexive property, or symmetric, depending on what you name it. And then to do angle, side, angle, you needed another angle. So again, you needed SRQ to be the same as PQR, okay? And that is true because alternate interior angles are congruent. And then you could have the triangles are congruent by angle, side, angle, okay? All right, so let's move on to when we've got some complete blank proofs, okay? So we've got two examples of these. I'm going to try the first one, and you could try the second one on your own. Okay, so first off, my givens are going to go on the left side. So I know that NER is going to be congruent to angle NVR, and that is given. So let me make that mark. NER, which is already marked, NVR. Okay, so I'm good. My second given is that RN is going to bisect angle ERV, and that is given. Okay, so if RN is bisecting an angle, I know that this angle is going to be the same as that angle. Okay, so what I can now say is what I just marked. So I marked that ERN, that is going to be congruent to VRN. Okay, so again, if you've got a bisector, it's going to split the angle in half. So I named it ERN and then VRN. Okay, why can I say that? That's the definition of a bisector. Okay, all right, so I need one more mark, and I know that this mark right here, I'm going to say RN is congruent to RN. Okay, again, you could say NR, but that's going to be the reflexive property. Okay, so now that I've got three marks, I know that that is going to be angle, angle, side. And I know this proof right down here is going to go here. So ENR is congruent to triangle VNR. Okay, so a couple things. Your givens are always going to be at the middle. Could I flip-flop these? Of course. Okay, once you do the givens, you can do it any order you want it to. So if y'all saw the reflexive property and you wanted to put it first, you're more than welcome to. Okay, all right. So we're going to let you be free on your own on this one. Notice I've given you 5 boxes, and you are going to have to fill all of them, okay? So why don't you try this one on your own? Press pause, and then we will go over it. That's pretty tricky, not going to lie. So when TR and MN are bisecting each other, that means if this line is going to cut in half this piece and this piece. So I know that this part is equal to this part. And then this line right here is going to cut apart this half and this half. Okay, so if you've got a line bisecting another line, you're going to get basically like a midpoint. Okay, so that was a given, and then you had to kind of make these marks and then name them. So I started off with TP, and I said that it was the same as RP. And the reason I can do that is that's what the definition of a bisector is. Okay, same thing up here, NP and MP are going to be congruent because that's the definition of a bisector. Lastly, I've got some vertical angles. So I named it MPT, and then you're going to have to start MPR to name those two vertical angles. Again, you can't say angle P because you don't know which one you're talking about. Okay, so the reasoning was vertical angles are congruent, and then lastly I have side angle side. So I wrote down this proof down here in the bottom left that I have proof that those two triangles are congruent. Okay. So proofs are really hard, okay? It takes some practice, and there is lovely IXL on it, or there is definitely paper practice, okay? So you're more than welcome to ask a question if you have it. Otherwise, get started on your practice.